Hey Valley Middle, welcome back. Tonight we're going to be solving real-world ratio problems. Before we do that, let's get started as always with our trivia question. How tall was the tallest human ever recorded? What was that person's name? Those are some interesting questions, and I think you're going to like hanging around for the trivia question. Tonight officially, our target is 6.6a. I can solve real-world ratio and rate problems. You're going to need a calculator, so if you haven't got one, go grab one right now. All right. Start with the problem as always. Sweet Baby Ray's barbecue sauce, the best barbecue sauce, is sold in 8-ounce bottles for $1.50. They also sell 16-ounce bottles for the same price per ounce. How much is a 16-ounce bottle? These are the type of problems we're going to be solving tonight. Well, we've learned in earlier lessons that when you set up two ratios like this, the cross products will be equal. So what I did was I stacked my ratios, 8 to $1.50, 16 ounces to something, and I multiply this way. This way is $24. So 8 times this one is going to have to be $24. Well, the only way to make that happen is to slide 3 in there, because 24 divided by 8, of course, is 3. So I used some logic in knowing that these cross products were equal in order to solve that problem. I'm going to show you a method tonight I call using the box. That'll make proportion questions, ratio questions like that a snap. All right, let's get to it. Tonight, our words of the day. First of all, two equal ratios will be proportional. And a proportion is an equation stating that two ratios are equivalent. So the cross products will be equal, like 1 to 2 and 2 to 4. I have one glass of milk for every 2 cookies, or 2 glasses of milk for every 4 cookies. These are proportional. And if I multiply the cross products, 1 times 4, I've got 4. 2 times 2, I've got 4. And that's the quick way that I can check that. Tonight, oh, it's Barney's going to be here. Barney, what are we going to do with the box, and is it any good?
The box is super-de-duper.
Great. Go ahead and pretend that you didn't watch him as a kid, but I think we all know you did. All right, so we're going to use the box, we're going to use Barney, and these hieroglyphics? No. These here are just a bunch of little arrows showing that what you're going to be doing tonight, and they look like hieroglyphics, right? Well, let me explain further. Let's try using the box. I put some ratios in here. I stacked them. So we've got 5 to 15 is the same as 2 to something. And now if they're proportional, this has to work. So what I'm telling you to do is you stack the ratios and then you multiply diagonally. Well, the only way I can multiply diagonally is here. So I'm going to throw this guy in here. So I'm going to multiply diagonally, and then it says divide. So I'm going to divide this way because there's only 2 numbers left to divide. So I do 2 times 15 is 30. 30 divided by 5 is 6. And of course, that works. 5 times 6 down here would be 30. 2 times 15 would be 30. So I'm proportional. But what if I took and, let me throw these guys out here, I just got rid of another number. Let's say that this was the number that was missing. It's always going to work. I still multiply diagonally. Put this guy, I'm going to multiply diagonally, and then I'm going to divide the other 2 numbers. That's what my hieroglyphics are, all the different ways that you can use this. So I do 5 times 6, that's 30. 30 divided by 2 is 15, and it worked. What if this number were gone? It's going to work. It's going to work. Multiply diagonally, divide the other numbers. Okay? There it is. I stacked them, multiply diagonally. 2 times 15 is 30. 30 divided by 6 is 5. It gives you the missing number. So your answer will be in the empty box. You multiply diagonally, divide the other 2 numbers, and then let's just check to make sure we're right. 2 times 15 is 30. 5 times 6 is 30. Equal ratios are proportional. The cross products will be equal. You stack them and check. Just that simple. Even if this one is missing. Multiply diagonal. Well, I can't multiply diagonally this way anymore, so I'm going to multiply diagonally this way, and then I'm going to divide the other 2 numbers. 5 times 6 is 30. 30 divided by 15 is 2. It's a marac. Sorry, that was from Caddyshack. Yeah, it works. All right, so what are we going to be doing with this tonight? Well, there's really two types of problems. Are the ratios equal problems? And we're working on a couple of those. And then find the missing value problems. And we've kind of even done one of those. So let's start off with, are these ratios equal? Here are a couple of questions, typical of what you'll be asked in testing situations. 20 children from 6 families to 16 children from 5 families. Are these equivalent, or are these ratios proportional? So I just set them up. 20 children from 6 families. I stacked them. 16 children from 5 families. Okay, I stacked them, multiplied diagonally. 16 times 6 is 96. 20 times 5 is 100. 20 to 6, 16 to 5, these are not equal. They're not proportional. You try this one here. Go ahead. Let's see how you did. If you fill the numbers into the box, you did 5 pounds of dry ice in 30 hours, 4 pounds in 24. Then you multiplied the cross products and you got 120 for each. These are equal. These are proportional. Very simple. You pretty comfortable with that? I think so. Let's move on. The other type of problems will be finding the missing number problems. And here's an example of one of those. How many milligrams of calcium are in 12 servings? And this is a real world problem because you've got it for 1 serving and for 4 servings. So what are you going to do here? I'd use the 1. So let's just pop the numbers in. We know that it's 300 mg's in 1 serving. And we want to know how much is in 12 servings. Right? So we've got 3 numbers out of 4 in the box. We can do this. We can multiply diagonally. And then we can divide. And we'll get the answer. Just going to slide this over, get my calculator. All right. So go ahead and do this one. 300 times 12. 300 times 12. I got 3,600. And divided by 1. Of course, it's 3,600. Anything divided by 1 is. So pop this guy in. All right. And I can divide, and I can check my answer too. 300 times 12 would be 3,600. 3,600 times 1, it's 3,600. And that's it. 3,600 milligrams in 12 servings. The box works. It's super de-duper, as Barney would say. All right, here's another one. For every 18 people who have a sore throat, there are 2 people who actually have strep. If 72 patients have sore throats, how many of these would you expect to have strep? Well, let's set it up. We've got 18 people with sore throats. There is 2 who have strep. So 72. And this is where we're looking for our answer down here. We're not sure what that number is, so I'll just place that up there. Well, let's do it. Let's multiply diagonally. And then we're going to divide the other 2 numbers. Get our calculator out. Clear that baby. 72 times 2 equals 144. And then we're just going to divide that by 18. I got 8. Go down and grab my answer down here. All right. Well, we know that 72 times 2 is 144, so I'm just going to double check and make sure my cross product here, 18 times 8, 18, oops, 8, I can do that backwards, times 18 equals 144. So I check my cross products to make sure they're right, and that's it. I mean, it is just a slam dunk. Using the box, it's super de-duper. Sorry. All right. Here's another problem. Make sure I didn't skip one here. Nope, we're good. Franco drove 200. Oh, this is the yeah, but what if I get a weird number, Mr. Dudley? Check the cross products, see if it works. So anyway, we'll do this one. Franco drove 203 miles in 3.5 hours. At this rate, how long will it take him to drive another 29 miles? So, well, I'm going to show you this one. I'm going to set it up. It doesn't matter where you put the ratio. So I'm going to say he drove 203 miles in 3.5 hours. And if you were to drive 29 miles and the ratios were proportional, how many would it be? It doesn't matter which ratio you put in the top or the bottom. You're always going to have an empty spot, right? Okay. Same thing. We'll multiply diagonally. and then we're going to divide. So let's do it and see what happens here. Okay, whoops, clear that baby out. So we have 29, oops, sorry, 29 times 3.5 equals 101.5, but then I have to divide that by 203, divided by 203. It's not going to be right. It says 0.5. Okay, this is that Yabba thing. Let's check to make sure we got a weird number. Let's make sure we got it right. Okay, go back and check our cross products. So we've got 29 again times 3.5. That was 101.5. So let's just go back and try the other side. 203. Did this one was 101.5. We'll go this way. 203 times 0.5 equals, oh, it works. It will work. Use the box, Luke. All right. A little Star Wars for you there. Your turn. Try to solve this problem here. Go ahead. All right, let's see how you did. I set this one up like this, 300, and then I had 120 and 24, and my answer was 60. If you check your cross products, you should be good. All right, let's try the next one. Go ahead and try this problem. Let's see how you did. All right, let's see, 3 gallons of orange juice at $5. How much is 5 going to be? Well, I know 6 would be at $10. 3 to 5, 6 to 10 would be equal, but if you put it in, you will get this. 8.3 repeating, or 8.33. Weird number, right? But it works. This is 25. 3 times 8.333 repeating will be 25. Okay? I think you're ready for the ticket to the show. You've been very patient, but I think you learned a lot tonight. Here you got a missing number problem, and this one here you've got are they proportional? And you do not have to explain. Go ahead and do that. While you're copying that down, I'll let you listen to Barney one more time.
The box is super-de-duper.
All right, sorry about the long video. Here's the answer to the trivia question. Who was the tallest person, and how tall was they, or how tall were they? It was Robert Pershing Wadlow. These are genuine, real pictures. He was 8 feet 11 inches, almost 9 feet tall. Yeah, these aren't kids. These are his mom and dad and his family members. Crazy. A couple interesting facts. He's born in February of 1918. He died at a relatively young age in 1940. 8 feet 11.1 inches tall. He was buried in a coffin that was 10 feet 9 inches long. That's crazy. His shoe size was 37 AA. Okay, I'm thinking those babies were special ordered. Can you imagine what a pair of Nike Roshis would be? Especially if they're personalized. All right, thanks for a good evening. Bye.